it not lat long, something, whatever you feel is the proper name. And then that flag will control several behaviors in the same way. Okay.
So will you cover how to say necessity from IDL?
Probably, yes. I want to cover also this thing with how to make, to just show you an efficient way to make some trend plots from annual files, for example, or from monthly files or whatever. And then I will only answer questions. So if there is something, well, we will make a discussion as well because Nick proposed to discuss a couple of things, and then we can answer questions depending on your personal needs. So let's say you have several files with data, and you want to combine them and make a line plot that shows some trend. This is the whole program that does it. Nothing. You don't need anything else. So you define whatever you want to create and plot. You read it and you plot it. Let's go through them one by one. Defining. Let's say you have annual years of model output. It can be anything. I'm just picking the example. And I say I want 5 number of years. You create an array with the files. I don't have in my computer several files, so I just replicate the same file all the time. Okay. So this is practically an array of files which are strings. I name the years, and I say the years are 5. I create integers of 5 years, and I say the first one is 2000, and then it will be 2001, 2, 3, 4, 5. 1, 2, 3, 4. The number of, let's say the variables I need are these: OCIA, OCII, OCD, OCOcean, and all of them have the suffix total mass hemis. Okay? So I can put this inside, but it will be superfluous. And then I count them. There is no reason to say that this is 4. You can just count it. So you have to, well, I don't have to tell you that, you're all programmers. But you really have to be as much automated as possible. If you can figure out something from whatever you have, don't hard code it. So I read the number of variables, and then I create the data array that will be filled later. So I make the array which has the number of variables times the number of years. It's a floating point, and the default value is a floating point, not a number. Okay? Reading with the object way. Every file has a year, so we have to open 5 different files. So everything is in a loop of the years. For the year from 0 to n years minus 1, and the loop ends here. The object file is a new object, netcdf. The file name is files with the index year. So it takes the first, the second, etc. And I also use the keyword quiet here because it's to suppress some blah blah. And then for all the variables I want to read, I do this loop. So I have the file open. I do a loop for reading the variables, and then I close the file by object destroy. Oh yeah, did I tell you that before? No. So in order to close this file, you say object destroy, comma, and the name of the object. And if you also include the temporary, then it will remove even that from memory, but it's not really necessary. So in general, you have to remember that, otherwise you might have serious memory leaks. Every time you create an object, you have to destroy it when you don't need it anymore. And the moment you don't need it anymore, you don't have access to the information of it. So if you say if you go here and say, oh, I create an object variable from the object file, and then I close the file, this is empty. It has nothing, you have no access to it, because everything goes with pointers. So you can only close the file when you finally have something into a structure or into an array. And so, open the object file, access it, close the object file. Open the object, access it, and then destroy it. So for all the variables that they exist in this file, you say the object variable is from the object file, get the variable this, and you loop over these ones. Okay? So this is an object, and you access it by saying the data is this one. So from the object variable, get the data, and then into this table that we created, set the third number, which is the global mean. Okay, yeah, for those of you that don't know the Model E output, reading the hemis is an array of 3 elements. It has the southern hemisphere mean of whatever variable you're reading, the northern hemisphere mean, and the global mean. So by saying this, you say that the third number, which is the global mean, is the number I want. Okay? And I just put some noise here to have something else other than a flat line, because I'm using the same file all the time. So this, you don't need it. It's only for artificial noise. And then I destroy the object. Now, you have to destroy only the objects you created like this. When you create an object like this by calling a method in another object, by destroying the parent, you destroy all the children. So this one destroys the file and the object variables. So we have created the data that has the numbers. Okay, up to here, it's a simple nested loop that goes through files and reads something. Only the reading is a bit funny. And then for plotting, we say this is going to be a postscript. We open the device. I said that last time. The file name is this. It's going to be an encapsulated postscript in color. And here I set another variable, which is internal to IDL. It's called p.multi, and it controls how many plots will be available in the single page. So when you say it like this, you say that window number 0, which is the first one, will have 2 lines and 2 columns. Sorry, 2 columns and 2 lines. And this starts from 1. You cannot have 0 plots someplace. You have to have 1, 2, 3, etc. And so this is the index number of the window, and these are the index numbers. These are the counts of the plots. So it will create a window with separated in 4 things. And then for all the variables, I plot the x value and the y value, and I give a title. So this reform just eliminates the dimension 1. You don't want to have an array. Well, it will work, but it's ugly. You don't want to have an array that has dimensions 1, 5. So this reform eliminates all the the 1 element dimensions. So for all the plots, for all the variables, there are 4, I use the keyword plot, not oplot, which means overplot. If I use plot for the first and oplot for the others, everything will be plotted in the same thing. If I use 4 times the keyword plot, every time the plot will be overwritten. And since I am using 4 elements, I will create 4 different plots. And then I replace the p-multi with the default, which is 5 zeros, and I close the device. And this will create that. plots. The titles taken automatically from the long name, from the short name. And this is being calculated automatically, the years that I set. And here we go. Of course, we can play with colors, we can play with legends, we can overplot things, but I showed you some of these things yesterday, no, last week.
Where did you set the positions that those different plots appear in?
If you just define with the multi keyword, you define that you want 4 plots, 2 by 2.
Oh.
Then it splits them in 4 and puts them in the center. But if you want more control, you can play with the exact control of the exact place of the plot. So instead of putting one plot over the other, you can say the first plot will be from the left to the middle, and then from the middle to the top. And then you create the positions of everything, and then you plot them properly. And then it will not overwrite anything because they are positioned differently in space. So I can go on forever, but I really want you to ask me some questions. I think that I'm trying to motivate you to start using that thing. It's really easy, really customizable. I mean, there's no way to cover everything here. I can explain you other things if you want to make this plot nicer. But I don't know. Is there something really fundamental that you would potentially like to do and you don't know where to find your way out?
How do you use different projections? Like, I guess IDL is supposed to have million projections which will be used.
Projections, you mean
geographic representation of
like ITOF and things like this?
Huh?
Like a Robinson projection and
yeah, stuff like that.
Yeah, you can use them. You have this close to you? Anybody? No? So anyway, if you go here to map continent, to map set. Is it map set? Map set, yeah. So the keyword map set, which defines that what we are going to plot is something that has to do with the Earth, has flags that they call azimuthal, conic, cylindrical, gnomic, hammer, Lambert, Mercator, blah, blah, blah. So we just say slash something. And if you want to control that from another function, you can play with the keyword set thing. And you can say, for example, orthographic equals a keyword, and then you control that from the outside. You can play like this.
So basically just one keyword.
Yes.
And as long as you do that before you call contour, it warps the contour.
Yes,
too.
exactly. So you have to define that you are plotting something that has to do with the Earth before doing the actual plot. And then it will it will automatically assume that this is something that has lat long information. And also you can instead of giving lat long as a single dimensional arrays, you can give 2-dimensional arrays for them. And then it will be able to plot something that is not in a regular grid.
So basically you give this plot, keyword to the first plot you are using, and then you use full plot and you automatically.
Yes, so I'll show you now. So if I go to plot here. So here I select cylindrical, okay? It's white, you don't see it, but now you do, okay? I select cylindrical. If instead of that I say Robinson, then is map grid, and then is map continents, and then is contour. So if I say Robinson, it's, well,
Which map continents have to be with contours or for sure?
the contours?
Won't the continents be under the contour?
No, just a minute. These contours are the hatch. Are hatching. So if they are the same color, you don't care.
Oh.
And color contour. have it. Yeah, well, I haven't set it properly now. It's not in the correct order. But if I put contours, let's do it. I need to make some changes. I haven't set it properly for doing that, but it can happen. Yeah. You can do it. It's you just have to put in a proper order, as John said, but George said, but I haven't done. So yes.
It's not about body. Object variable, object VAR, was an object because the get variable told it to be.
It's an object because the get variable returns an object. So, oh, I forgot something really important. So everything here has to do with all the plotting I showed you. Is like this, okay? I have a program or more, and then I call it, and then I say end. This is only working from IDL inside. If you want to call IDL from the shell, you have to do a little trick. So you have to have a file called .idl. Well, in reality, you can call it any way you want, but the convention is to have an .idl extension. And then this file is doing whatever it wants to do. So for example, it sets something, it's calling some function, and then you type exit. And in order to run it, you say IDL x IDL, like this, from the shell or from a script or from something else. And then, whoops, no license, go away, yes. So it's now it started doing something, and it's running, and when it will finish, it will take you back to the prompt, and then you can continue doing something else. So you can call multiple IDL scripts from the command line, and you can. And what's the deal though? You have to be careful with two things. Number one, if you do not put the word exit here, then it will not use it in the IDL session, and then at the end, it will not exit the IDL session. So you will end up with the IDL prompt after the end of the program. That might be needed, especially for debugging, because you might want to see what happened there. But if you really want to exit the IDL and then continue doing something else, you need this exit keyword. Number two, you cannot have a plot, you cannot have something like this being called. So the file do_plot.pro cannot be called from a script like this, because it contains information on what to do. It can only, this file can only call things that they are single programs. So in order to do it, you need to have a .pro file. Forget about the file itself, okay? That it will start, it will be a program or a function, procedure, sorry, or a function. It will end here, saying end, and that's it. There is nothing else in the file happening. Only procedures and functions, function declarations. And if you are in IDL and you call this file, nothing happens. It just compiles it, and there are no instructions on what to do with it. It just compiles it. Okay, so if you want to invoke IDL from the shell, you need to have .pro files that have no instructions, only functions and procedures, and the .idl file that says to IDL what to do, and then you need the word exit at the end. And yeah. Also, another thing that Nick suggested to discuss, and I think it's a very good idea, is why IDL? And I told you my experience about Python versus IDL the other day. I can also tell you my experience about IDL versus Excel, but it's not even fair to do that. But I cannot tell anything about other programs like, I don't know, maybe Grads or maybe R or maybe MATLAB.
What's about Ferret?
So with Ferret is handling data in a very nice way. It is very easy to take slices of the data. You can. It is supposed to be used only for the Earth, for lat long data. So it is extremely clever in understanding how to deal with lat long areas. You can just say, do a normalized average, and it knows that you mean this is the globe and these are the coordinates. It is very clever in handling data. The two caveats I had with Ferret is, number one, some very basic things are extremely difficult to happen. One of them is do loops. It is very counterintuitive the way it handles things, simple things like this, because it is not primarily designed for that. And then number two, I really hate the plots the way they look. Although it makes extremely quickly very plots, they really look ugly.
What might be ugly? Maybe it's only
it's my personal taste.
Okay.
It's my personal taste. I think even if you put extremely thick lines, you cannot really put them in a poster or a presentation because they might have some gray shades. And then the default color tables are, I don't like them. It's a personal taste.
Yes, but it's also everything is for customized at the same time as IDL.
Yes, but
so
but some
maybe you use only default.
No, I was using Ferret for a couple of years.
Oh.
So it's and at some point, well, less than a couple of years, because at some point I just gave up. I said, okay, I just can't do it. And it was not only the visual part, it was also the fact that certain things cannot happen very easily.
What about the Python?
Python?
Yes.
For Python, I really love the plots that it creates. It is a very good thing that it is free. But in order to have a full functionality, you need to install several things. And then this means that if somebody shares with you a code that is written in Python, you might not have all the add-ons installed, or which is not necessarily tricky. Then Python is not having a manual which is so clear and so nicely written as IDL. IDL is the best reason to use IDL is the manual. It's fantastic.
But Mathplot has the instruct manual 800 pages.
This is 6,000. You don't read it. It's a reference page.
Okay.
It's a reference thing. And but in order to find something, you need to have a good guide. And for the guide in IDL is just this little theme book. You don't need anything else. Only this. And the moment you start getting familiar with IDL, you don't even need the thick manual. This one will suffice. For Python, you have for every single piece you add to the basic Python interface, you need to have a separate manual which is written in a different way, and it's really a mess to find out what's going on there. This is at least, I had a great difficulty to find out how to do simple things in Python, just because it was spread in different manuals. And what else? Yeah, and also in Python, some things that I would like to have, well, at least one thing that I would like to have is not supported yet. Officially, you cannot do it. And this is creating multi-page PostScripts. You can create encapsulated PostScript for a single page. You can create a multi-page PDF. You cannot create a multi-page PS. So it's just not enough for me, not good for me. And other than that, I totally love Python. It has a very clear way to write code. Writing code in Python is fantastic. Especially the thing that it forces you to use proper indentation. I love it.
Where did you get, you have multiple copies of that manual?
Yes.
Where did you get those?
Brian had 3.
Oh.
So, yeah. And I don't know if others have used MATLAB and know IDL as well, so they can tell us their experience between two proprietary packages, which one is best. I believe, my sense is that they are equally good. Concerning R, I know that if you want to do statistics, go for R, not for IDL. Because it has built in several things that you might use. In IDL, you have to develop them yourself. But in our community, if somebody shares some code with you that does some visualization, most probably it will be IDL.
Yeah, I think that's probably one of the most important points. That very often you get IDL scripts with data sets in this community. You rarely get an R script or a Python script. So this is very convenient. I found it very convenient. That I use some satellite data, they give me an IDL script. I use some, whatever. I use some emission data, they give me an IDL script. So that's for me, that's the biggest advantage for using IDL. That's the main reason why I stayed using IDL.
And by the way, for the Discover users, as of yesterday, IDL on DALI, we have IDL 8.1. So if you load the module IDL 8.1 instead of 7.1 that I guess you're loading now, then you have some very, very nice capabilities. And one of them is this. You can create a zero element array. This is fantastic. I don't know why we had to go to version 8 to have it. And you can also create some other fancy things like you can set plot is also a function, and when you do this, it loads a graphical interface. Goes to the background as well, and then you can play with the plot itself. It's really nice. And then you can save it, you can change colors from here, just by calling plot as a function and not as a procedure. It's really cool.
It is in DALI already?
It's already on, yesterday they installed it.
Okay.
So you just have to load the module IDL, IDL-8.1.
Are you going to send the examples today to
Yes,
us?
all of them.
That's great.
All of them. And yeah, unless you have something, I can still stay here and explain to people that might be interested about object-orienting things. I can do that, or something else. If you want to learn something extremely technical that I skipped, or yes, if you want to learn how to create templates to read ASCII files, I can also say that, but it's already 2 hours, and if somebody wants to stay more, I'll stay more. Tracers, people who is using tracers, you are using tracers. I have also some extra interface for tracers, if you want to see it. Interface? Yeah.
I mean, I have my own codes to trace the stuff and trends and stuff.
Yeah, I mean, I have a code that does something like that. You create an object which is called tracers, and then you have to give also a file, a TAIJ file. So you create an object called tracers, and then you can say that let's say you want sulfate. So you say print from that object, from that object, get trace sulfate. Tracers. No, just a minute. Object name, yes.
Is it case sensitive?
Okay. Tracer. Okay. Freaks out. So, hey. It is an object, okay? Why it's not working? I don't know why it's not working. Maybe I've done something stupid. Anyway, I can show you that later.
But what does it do?
It's so the idea is that you can say I want the sulfate tracers, and then it knows which ones are they, and it gives them to you. And then if you use the mass model or the Thomas model or the matrix, it knows how to, depending on the file you gave it, it knows which model it is, and then it knows which files to return to you. And then so you can get a list of these in an array of a string array, an array of strings, and then loop over this array and do whatever you want with the tracers, add them up or do something else. I guess nobody wants to listen to object-oriented.